Look at the night sky long enough, and sometimes it does something unexpected. It responds. Not with sound, not with impact, but with light. A slow, silent glow, stretching across the darkness, folding, dissolving, returning. We call them auroras. They are often described as beautiful, but beauty is not their purpose. Auroras are not decoration. They are not messages. They are not warnings sent to us. They are traces of a constant interaction between a star and a planet. An interaction so stable, so continuous, that we forget it exists until the sky lights up. Tonight, we will not chase beauty. We will follow the physics, hidden behind the glow. From Earth, the sun appears calm, reliable, predictable. But this calm is an illusion. The sun is not a solid object. It is a sphere of plasma, where charged particles move freely, and magnetic fields twist under immense pressure. These magnetic fields stretch, tangle, and sometimes reconnect violently. When they do, the sun releases energy, not primarily as light, but as matter. Electrons, protons, ionized particles. They are expelled into space at enormous speeds, forming a continuous flow known as the solar wind. This wind never stops. Most of the time, it is subtle. But sometimes, the sun releases far more energy than usual, and space becomes active. If Earth were directly exposed to this continuous flow of charged particles, its atmosphere would slowly change. Over long time scales, solar particles can interact with atmospheric gases, altering their structure and redistributing energy. Earth avoids the most extreme effects because it possesses something rare: a global magnetic field generated deep inside the planet by the motion of electrically conductive material within Earth's core. This field extends far beyond the surface, forming a vast magnetic region around the planet. It does not stop the solar wind. It reshapes it. Earth's magnetic field is not uniform. It stretches outward on the side facing the sun and extends into a long tail on the opposite side. Near the poles, magnetic field lines curve inward and descend toward the upper atmosphere. These regions act as controlled entry points. Charged particles from the solar wind are guided along these invisible paths, spiraling downward. Not randomly, not everywhere, only where the geometry allows. Auroras do not choose their location. They follow the structure of the field. High above the surface, far beyond weather systems and aircraft, incoming charged particles encounter atoms of oxygen and nitrogen. These collisions do not burn. They do not produce heat in the usual sense. They excite. Electrons inside these atoms are pushed into higher energy states. When they return to stability, they release energy as light. Green light, produced by oxygen, is the most common. At higher altitudes, oxygen can emit red light, rare and faint. Nitrogen contributes blue and purple hues. Each color corresponds to a specific physical interaction. Nothing is random. Auroras are precise outcomes of atomic physics. Auroras rarely remain still. They ripple. They stretch. They drift across the sky. This movement is not caused by air currents. It reflects changes in Earth's magnetic field. As solar pressure fluctuates, the magnetic field deforms, then relaxes. Each adjustment redirects the paths of charged particles. The sky becomes a visible map of invisible forces responding in real time. Auroras are almost silent. They occur at altitudes where the air is too thin to carry sound. No explosion, no echo. They demonstrate an important truth. Power does not require noise. The universe operates quietly, through structure and interaction, not spectacle. Auroras are not exclusive to Earth. They appear on planets, with magnetic fields and charged environments. On Jupiter, they are enormous, powered by both the Sun and interactions within the planet's own system. On Saturn, they trace near-perfect rings. On Uranus, they appear tilted and displaced, revealing a magnetic field unlike any other in the solar system. Auroras act as fingerprints. They reveal the invisible architecture of planetary environments. During periods of intense solar activity, auroras expand. They move toward lower latitudes, becoming visible far from the poles. These events are visually striking, but they also indicate increased energy entering Earth's magnetic system. Such disturbances can affect satellites, navigation systems, and power infrastructure. Auroras themselves are not harmful. They are indicators. Scientists study auroras, not only for their appearance, but for the information they carry. Their brightness, shape, and motion reflect conditions in near-Earth space. Auroras transform light into data. They allow scientists to monitor solar activity and magnetic responses in real time. The sky becomes an instrument. Auroras remind us of a simple reality. Earth is not isolated. It is not sealed. It exists within a continuous exchange of energy. Every aurora is evidence of that exchange. A reminder that the boundary between Earth and space is not a wall. It is a conversation. Hidden science is not hidden because it is secret. It is hidden because it is constant. And only sometimes it becomes visible.